Thank you, thank you. Hello, everyone. My name is Christian Klein. I'm the Technical Product Owner and Data Protection Officer at Elastisys. And for those of you who are not familiar with Elastisys, we are the ones who are sponsoring the pizza tonight in exchange for you listening 2 more minutes about, talking about ourselves. We are a 50 people company with offices both in Lund and in Umeå. We specialize in cloud native, Kubernetes, and information security. And we offer around these technologies managed services, self-managed services, consultancy, and training. Our flagship product is called Velkin, which is an application platform for software critical to our society. So it sits pretty much between the application and hardware, servers, virtual machines, whatnot. And it integrates over 20 plus cloud native and open source projects in a very careful and secure by default manner, so as to essentially make your CISO happy while at the same time make your CTO happy because you can innovate securely and at speed. However, in order to reap the benefits of Velkin, and in fact, in order to reap the benefits of any kind of security hardened Kubernetes-based application platform, your application needs to be written in a certain way. So otherwise, you will pretty much end up with a dialogue like in this cartoon. So today, my colleague Jakub will talk to you more about how exactly to design your application so as to reap the benefits of the application platform and avoid a disappointed boss like in this particular comic. So without further ado, Jakub, the floor is yours.
Thank you and welcome everyone. It's great to be back here at the Fou Café after just a month. At the beginning of February, I had the pleasure here to talk about the certification in Kubernetes. And back then we had just one person that came here not for the pizza. I think now is a progress, we have two. So welcome to my talk titled Cloud Native Non-Functional Requirements, Building Scalable, Resilient, and Secure Applications. Let's start with the goal that I have for this talk. So basically, I would like to explore the relationships among guiding principles, architectural approaches, and requirements and implementation details within the area of cloud native technologies. About myself, few words. I'm Jakub. I have a PhD in computing science from Umeå University. They're in the north of Sweden, and I work at Elastisys. We have one office here at Lund, close by, and one our headquarter there in the north in Umeå. And I'm there with kind of this dual role as both cloud native architect as well as the Linux Foundation instructor and training manager at Elastisys, responsible for all of our training activities. So if you have any questions later on, it's not topic for today, but I'm also fine with answering those questions related to that part. This talk today, I divided into 3 parts. So I would like to start with providing some context for this session. So basically defining these 3 concepts of cloud native, non-functional requirements, and application platforms. Then I would like to move on to these guiding principles and common approaches to achieve the scalability, resilience, and security that we want to have within our application, within the system that we build. So we will kind of start with high-level overview, context, then maybe something in the middle about the still a little bit less concrete things, but what we promised to give you in this talk, in this session, is also some crisply formulated requirements and implementation details on how that you can apply within the projects that you work in, and that will be the last part when we talk about specific requirements and implementation. Of course, because of the time limit here, I will not talk about everything, but I will try to give you a nice representation, nice selection of those requirements and how you can implement them, and then we'll also point you into kind of right directions where you can find more about those, if that's something that is interesting for you. And for those requirements in implementation, we will kind of divide them into two parts of what you can get from a proper application platform, kind of out of the box, and what you as an application developer should focus on, and what you are still be responsible to implement. So let's focus on the context now, and I will actually give you an excerpt from few different organizations, how they define those. So these are not really my words, but kind of what those organizations, how they define those concepts. So according to the Cloud Native Computing Foundation, cloud native technologies empower organizations to build and run scalable applications in modern dynamic cloud environments. These technologies enable the loosely coupled systems that are resilient, manageable, and observable. And combined with robust automation, they allow engineers to make high impact changes frequently and predictably with minimum toil. So basically we have some kind of ecosystem of different projects, different tools that then will allow us to kind of apply this approach of making rapid changes with our application. We observe that we need some new feature, and then how we can really quickly roll it out without kind of causing downtime and so on. Then the non-functional requirements, according here to the Scaled Agile, they define non-functional requirements as system qualities that guide the design of the solution and often serve as constraints. And these non-functional requirements specify various system qualities and attributes such as performance, scalability, security, usability, and maintainability of the whole system. And we see here these constraints, which some of you will say, like why I should be limited by something. But sometimes actually constraints, and in this case, that's how I see them, it's also something positive, like almost like a kind of guarantees. If you will do something in a certain way, we can guarantee you positive outcomes. So, right? So it's not necessarily something negative. And finally, even though not included directly in the in the title, I would like to also define this application platform term. And here I took one from kind of a leading organization within that area, so the Red Hat OpenShift product, when they define the application platform as a comprehensive set of tools and services that streamline the entire application lifecycle, from development to delivery to management of application workloads. So it's to some extent maybe similar also to the cloud native, without kind of focusing on the cloud part. So it's not so much about maybe the technologies itself, but rather changing the focus on the application itself. So here we'll try to combine those definitions and talk about the application running in the cloud and having some underlying platform that will help you with implementing those non-functional requirements. That was it about the first part. So now let's move to the second part, the approaches and principles. So here I want to discuss various approaches and principles that we would like to use in our for our application in the system, the platform, in order to make sure that the whole environment is scalable, resilient, and secure. So one of the commonly used approach here, you saw it also in the definition of the cloud native, is the loose coupling. And this is an architectural style that ensures that the components of our system, often referred to as microservices, they can be built independently, since it may be different teams that will be working on each component, and we don't want them to step on each other's toes. But so kind of opposite of what you will have in the tightly coupled system, when everything is kind of connected with each other, all the parts of the system. Here we want to kind of separate that, make the connections as loose as possible in order to make sure that we can benefit from scaling and of the whole process, so we can independently develop the components, assuming that we have some kind of agreement on the APIs in between those, that we can deploy new versions of each components independently, not having to synchronize, like when you are doing your new version and then I have to adjust to that schedule and so on. And that we can also scale them in the sense of the number of replicas and so on independently. So if you have maybe a bottleneck in your system in particular component, then you can increase the number of replicas of that one and not necessarily of the all components included in your system. And yeah, when we talk here about those components, microservices, each of them, they have specific function, and ideally they are also reusable, so each other components can use them within their kind of workflows and so on. The drawback here may be that this approach is a bit slower to implement at the beginning because of the kind of the separation, and then you need to find out the way how they communicate with each other. You then deal, of course, with a distributed system. So that may be challenging, but on the long term, that should be a good approach in order to make it easier for you to scale as discussed earlier. The next commonly used approach within the cloud native, or rather maybe a system property, is observability. And that kind of defines to what degree we can get the insightful observations of our system, and to which extent those insights that we get about the state of the system allow us to make actions that then will be beneficial. So of course we have a set of tools that allows us to observe the state, and it can be kind of coming from the very low level metrics such as CPU usage, memory, disk consumption and so on, all the way to the high level and business relevant signals, such as the response time of the of queries, number of errors, transactions per second, and so on. And all of that gives us the current state of the system, and then we can identify again if something is happening, something going wrong, and then adjust the configuration of our system and make sure that it continue to function properly, and that we deliver the value to our end customers. And these are those various types of favorable outcomes. So it can be being able to find out that something went wrong and then to fix it. It may be also to make the productivity of increase the productivity of the application developers, because the observability tools is not necessarily that you only use them in production, but you can also use them when you develop new features and when you want to find out if your system is working correctly, and that the change that you introduce doesn't break something like for example, the transactions per second metric and so on. So as a consequence, this having observable system that will allow you to reduce the costs both of the implementation of the development, but also of the operation of the system in production. Another approach that is quite common here in order to achieve our goals with the scalable, resilient, and secure system is the automation. And here we have several flavors to it, going kind of from the most basic continuous integration, abbreviated as CI. That is a practice that we take the change of the code and then kind of run the pipeline that will produce produce a viable release out of that, release candidate. And then we kind of manually decide what to do with that later on, and that we can, within that pipeline, can run some checks, some tests in order to make sure that this is really a viable candidate for the release, or just it fails and then we know that we need to fix things. But we can also have kind of steps, a few steps more. So we can have the continuous delivery, abbreviated as CD, not to confuse with the other that I will talk later on, abbreviated in the same way. But basically, with the continuous delivery, apart from just kind of creating our release candidate, we also usually will deploy it into a testing environment that then we can verify if everything is fine with it kind of manually, and then decide if we want to actually deploy it into production or not. And then the last one, which is called continuous deployment, that allows us to go all the way from just implementing the feature all the way to the production, and kind of with rollouts in an automated way, and potentially also rolling back, since we monitor using the observability tools all our metrics, and then we can see, oh, something is not correct. Maybe suddenly the CPU or memory consumption increased, or maybe the number of transactions per second dropped. So that indicates that something is wrong with our system. So we can go take a step back to the previously kind of working version, and in that way fix that situation. And all of those tools, you see, they automate the steps that are kind of error prone, and then you as application developer or maybe an operator of the system potentially can make some mistake when repeating the same action again and again, kind of a boring task. So rather than relying on them making it every time correctly, we can automate the whole process and ensure in this way that we will have a resilient system that will not break during that time when we want to release a new version. Just kind of a visualization of those differences. So we have different stages of kind of starting from coding through building maybe our container image, or however we want to deploy our software, integrating that with other microservices, testing it, and then that part that will be the continuous integration, and then we can add another steps, which will be the release into maybe the test environment or all the way to the production with the continuous deployment. Then another principle here, and I would like to spend a little bit more time on that, is security. And now with the cloud native approach, the security tends to be built into the whole life cycle of the application. So rather than being an afterthought later on, I kind of at the end, or how I can protect what I already built, we should try to analyze all the potential threats and kind of create a multi-layer solution for that will ensure that our applications stay safe, even though now we see in the world more and more attacks kind of also in the digital world. So we need to really make sure that that our applications, even if maybe it's just dealing with some sport events and whatever you participate in which club and so on, but then there are some data that maybe you don't want to become public or end up in the hands of some malicious actors. The challenge here also is, since we are moving from more static systems, kind of the legacy ones that we had servers or virtual machines that will be kind of the same, running the same way for a long time, into moving parts with cloud native and containers, new versions being released very often and so on. So we cannot do the same manual checks on security aspects. So we need to ensure the same highest standards of security, but while adopting to this new way of deploying and creating software. So yeah, we have this rapid code changes, new releases potentially daily of our application, and also the infrastructure that is different because of the containers, orchestration, and so on, that we need to take into account. And also related to this one, we have, maybe you heard earlier about the DevOps and probably DevSecOps as well, but those kind of roles and approaches, when here this DevSecOps indicate that we actually include that security aspect in all the parts of this infinite loop of building the software, deploying it, and observing, and so on. So here, for the purpose of this presentation, we took a look on the white paper that comes from 3 national level institutions working in the area that is crucial for the society, and they come from Germany, Austria, and Switzerland. And then, yeah, as you can imagine, the document is actually in German, but they have identified those 4 security principles, and that here we try to kind of analyze them, and then from them identify the requirements that we should implement on the application level in order to make sure that our system stays secure. It is 92 pages in German, but yeah, we try to condense that and present that to you here in English and in a few slides. And for purpose of this presentation, let's also, apart from just kind of the definitions, let's try to look at an example. So let's imagine a fintech company that is developing a cloud native digital paying platform, and it tries to, of course, ensure security of that at all the levels by applying those security principles. So first of all, the security by design. So we want to ensure that the whole system and all of its components are designed already from kind of the ground, and from that first stage of designing the system, that we take into account the security as a core priority. It's not an afterthought later on, but from the beginning we think about potential attacks, potential unauthorized usage, and we try to protect and architect the system in the way that minimizes the impact of that security incidents. So in case of our company that is building that system, for example, they could use a security hardened Kubernetes distribution that already ensures that it installed properly and have some guide rails that will make sure that you do the right thing from the beginning, that you don't run as root, that you have proper pod security standard and so on, and that you cannot just by mistake misconfigure your system from the beginning. Some kind of a security by default in this sense. The second principle here for the security is minimum need to know. So it applies both to the components of the system as well as users or administrators, application developers, and so on. So each of those actors, they should get as minimum permission as possible in order to allow them to do what they need to do, but nothing more. So basically, yeah, when it comes to the networking part or the application itself, we should avoid the situation that kind of everyone has the admin right for everything, and then just really defined what exactly privileges they need and give them that. So in our case, if we have this cloud native system, we will have, of course, microservices, and they should have we should use some kind of role-based access control, and then only analyze which exactly actions each component needs to take, and just really give those specific actions to that system, to that components. So maybe here we have some kind of transactions, kind of payments, and we also have some user profiles, right? So if the component is dealing just with the transactions, there is no need for it to be able to read or write information about the people who are using it, right? So we should only be able to access that data that really is required for it. And the same, the developers shouldn't be able to access the production environment and just play with it. Just should focus on what is really needed for them in order to be able to develop and test their system. The next principle, the defense in depth. So we shouldn't just have like kind of one approach to protect our system and just one kind of layer, or like, I don't know, we have a firewall, so we don't need to protect anything underneath, right? Because that will protect us from everything, because no one can access our environment, right? So rather than that, we should always think about the layered protections and kind of multiple levels of complementary safeguards that will make sure that our application stays safe. So in our in the example of our fintech company, that for sure should be some kind of network security. As I mentioned, the firewalls, when you talk about the Kubernetes, the network policies for that, maybe encryption of the communication and TLS and so on. The application security, when we analyze all the incoming requests and verify that they validate them, ensure that there is no SQL injection attacks and similar, and also the data security itself, so some kind of encryption both in transit but potentially also at rest. Here to visualize that concept, I really like that Swiss cheese model and the graphic created here by Christian, when we can see those different layers, and here those refer to Kubernetes cluster itself. So we have access control, we have let's say not running containers as root, and so on and so on. And on the left hand side we have the data of the customers that we really want to protect. On the right hand side the potential attacks, threats, and this can be just malicious actors, or it can be just the hardware failures that then they will cause maybe unavailability of our system, and because of that the application will not be able to serve our users. So as the Swiss cheese having holes in it, but usually these holes don't go all the way through all the layers of our cheese, but rather thanks to the fact that we have these multiple layers, we increase the chance that the attack will be stopped at some point, right? So we are not perfect, we are human, we make errors when we implement things. The tools are not perfect, there are bugs in all the tools that we use and so on. So we cannot just think like with that single layer we will protect everything. We need to have multiple layers, and then thanks to that we increase the chance that our system will stay secure. And finally, the fourth principle, so redundancy, and that makes sure that our system, even though the failures will occur of individual components of the hardware, of software, that will not compromise both the security itself but also the functioning of the whole system. So we make the architectural decisions that will minimize the impact of the failure of the individual failures affecting the whole system. Of course, there may be some reduce in the performance and so on, but ideally that will not compromise the system as the whole. And going back to the example of our fintech company, that could be, for example, deploying our application across multiple cloud regions, or maybe even different cloud providers. So then having a kind of a backup options in case of a failure of one side or one provider, and having a failover mechanism to the other one, so that we ensure that there is no data loss, that the system continues to provide the value to the end customer without downtime. And finally, the one more approach here, and that relates to the application platform. And this is a common kind of software development principle. Don't repeat yourself. The DRY, also known as DRY, which tells us that kind of the duplication in our system is evil and we should avoid it, right? So whenever it's possible, whenever we need to repeat something, we should kind of eliminate that, and it can be both at the kind of logical level within our system, and that could be by abstracting that part and having a separate component that can be used by all of the other that will have to duplicate that. Or it can also be regarding the processes. So when we have a manual work that we have to repeat over and over again, then we try to automate it and eliminate the duplication in this way. So one could also see it as kind of controlling the technical diversity. So we try to ensure that we have one way of doing certain things that is reused across the organization. And so in this case here, we put this kind of, or this approach means that if we have some functionality offered by our application platform, we have to use it and not reinvent the wheel on our application layer, but rather just take what exists there, what is already implemented, and just add that, connect that with our application. So these were a little bit more higher level approaches and principles, and now I would like to move to the final part when we talk about the requirements and their implementations. And this is that kind of the part that I want to present this promised practical insights that you can use in your projects. So this will be this non-functional requirements and their implementations. And in this part of the presentation, I will use this convention that in the title that will be the category of the non-functional requirements. And then on the left-hand side, I will try to list what we can get out of the box from the application platform if we choose, if we use one, and then it's an appropriate one for our setup. And then on the right-hand side, that will be what is still left for the application developers to focus on and implement, because usually it's an application dependent or on that layer part that needs to be worked on by the application developers. So let's start with the database and state management. So the application platform should provide a solution for that, and that should be something that has, for example, the setup that is replicated and that ensures business continuity. So there are several replicas of our database, and then in case of one of the nodes goes down, we don't lose the data, of course, and then we take backups regularly, automatically, that we can use in case of any disaster, and then recreate the database from that. And of course, there are some bugs discovered and so on. So we want also the security patches to be automatically applied. So basically, we want this kind of to be abstracted from us as application developers. So then, what we can focus on is to make sure that we use that database system that is provided by the platform, and that will be still on us to kind of create the specific databases for each microservices, to create the users for that, to make sure that the users have the minimum permissions that is needed, and that we still need to kind of expose the credentials for those databases and to be able for microservices to connect to those. And also, very important part, really application dependent, so the database migration, right? While our application evolves, we change the schema or the type of data that we store there. So we need to implement those. But in order to have the benefits of the automation and to make the system resilient and so on, we need to keep the versions of our microservice backward compatible also with these changes in the database. We need to implement the automatic rollbacks, and ideally we also use, in case of Kubernetes-based platforms, init containers that allows us to perform those migrations in the automatic way and kind of stop the rollout in case something goes wrong, and thanks to having the rollback, being able to automatically go back to the previous version. So basically, here it's a diagram that shows this databases that are replicated, as I mentioned, several instances of our application. And basically, thanks to the fact that we use the database provided by the platform, we can kind of abstract that as that's abstracted from the application developers. They don't need to care about how am I supposed to manage a database to make sure that all those properties are achieved, but I just get the Kubernetes service that allows me to connect to that database and maybe do the kind of admin things, so create the database, create the user, and then just make sure that those applications, they have the credentials to be able to connect to their database and manipulate the data inside, but without kind of dealing with all of that underneath. Let me skip this one because of the time, but yeah, we can go back to this and see later on a bit more about the observability. I will point you into right direction. The next one will be then the automation. So we talk quite a lot about it. So we talk about the continuous integration. So you want the platform that or has it built or allows you to integrate your existing continuous integration solution with it. You want to be able to store the container images of your application within the platform. You want a platform that will give you the option to scan your container images and find the potential vulnerabilities in those. Ideally also kind of stop you from deploying those or using those containers that have those vulnerabilities. And of course, you want the continuous delivery or continuous deployment solution that will allow you to automate the whole process of going all the way to production. Sometimes configuring those continuous integration pipelines and then the continuous delivery or deployment solutions may be a little bit tricky. So it's also nice, especially when you have a bigger organization, to have so-called golden paths for your applications, which tells you like what kind of a template of how it should be done, and with common practices within the organization. And then as an application developer, you can basically implement, of course, the automated testing required for your application, and then utilize those golden paths and adjust them to your particular application. So the two common approaches that you can see are or the kind of the push style CI/CD pipelines, where you have, for example, GitHub Actions. If you use GitHub, that will actually have access and appropriate permissions to interact with the Kubernetes API server and push those changes as the successful kind of builds towards the Kubernetes cluster. Or you may have pool style CI/CD pipelines, such as Argo CD, that will actually live inside of the Kubernetes cluster and then pull those changes once they appear in the Git repository, and then kind of have a GitOps approach that will then pull that newest version of your application to some test environment, or maybe all the way to the production. Moving on to the security, we have the security by design principle, and then in order to implement that, the platform should be, of course, a security hardened Kubernetes. Maybe you know, by default, the default distributions of Kubernetes, they are quite open. Like it allows you to maybe start to work with it relatively quickly, but then many things you need to take care of by yourself. So ideally, you want to choose some some distributions that is already security hardened and ideally has this secure by default settings that will then make sure that you are not that you are doing the correct things from the beginning. But what you will still have to do as an application developer is to, of course, ensure the security at the level of your application code and so on. Also, you should distinguish here and separate the secrets that you have, such as passwords, some API keys, yeah, and so on, from just the ordinary configuration. And that, for example, in Kubernetes, that's very clear that you should do that. And then you have separate resources to define those, and then that allows you to then use appropriate role-based access control and make sure that only those that really need to access those secrets can do that, and not anyone else. The minimal need to know principle. So on the platform level, what should be provided is we have, for example, the namespaces that we can use different pod security standards for them, and then that is the most security hardened is called restricted. So that should ideally be the default setting for every new namespace that you create and you run your applications in, and that will make sure that you really make a conscious decision that if you really need some elevated permissions, by default you will be limited to only the basic kind of functionality that really is needed. And then also, some other settings, some other constraints, guide rails that will prevent you from running as a privileged user. But then still, as an application developer, when you build your container image, you will still need to make sure that, for example, in the Docker file, that you make sure that there is a non-privileged user created, and then you select that non-privileged user kind of as one of the last commands or instructions within your Docker file. So then you actually adhere to those standards, and the platform will allow you to run that application. For the defense in depth, we have also another kind of security guide rails that will prevent you from running containers with vulnerabilities. So as I mentioned earlier, we will have the container registry that will do the scanning, and later on we can have some constraints that will say, like, if we have some severe vulnerabilities discovered in that container image, that will never be allowed to run, for example, in the production environment, right? You will not be able to release a new version that contains that vulnerabilities. Very important for managing also the scaling the cluster and making sure that we have enough capacity is to always specify the amount of resources that is needed for each component. So the platform should enforce that, and they should also make sure that in order to prevent the situation that your component can talk with every other component in the network, we should also have network policies that should be required. And then again, these are only kind of the constraints, which I again here mean in a positive sense, because they help you to do the right thing. And then on the right hand side, we need to make work on as an application developers and implement those for our special use case, right, for our application, and make sure that the dependencies are up to date. So if there are some vulnerabilities discovered, we do the upgrade of our dependencies, of our libraries that we use in the container images. that we make sure that we actually test our containers, our microservices, and we know how much resources they require, so then we can set the quotas accordingly, not just take it out of the magic hat, but really understand what is required for our application to start, for our application to operate under a heavy workload. And finally, that we do the proper work and we understand which component talks with which component in our system, and then we can define a fine-grained network policies that will only allow that connections that are really necessary. The last one here, the redundancy. So for that one, what we need to do at the platform part is ensure the high availability setup of the Kubernetes. So we have multiple control plane nodes. Ideally, the worker nodes are spread among different servers or availability zones within the data center, or maybe different sites. And part of that is also that the system that we use supports probes that then can be implemented on the application level. So yeah, Kubernetes here, it supports several of the probes, and then they are used for the load balancing. They are used to restart the containers if they fail. They are used to check if the rolling updates are actually performing correctly and if the new version is working as it should, and then that can be used also to revert that rolling updates, or at least stop them. But then we need to, of course, implement them at the application level. And that can be, for example, if we do the database migration, that we make sure that the startup probe fails during that database migration, so that that component is not used until the database migration is completed. It can be the readiness probe in our container that is failing if the dependencies that are required for the operation of that microservice are not available. So then that one will not be used if that, like for example, that component depends on the database, and then the database doesn't work, then this component also shouldn't be marked as ready and shouldn't receive any workload from users, let's say. And then we also have several. We should also handle the properly the graceful exiting of our application. So our container should react to the kind of termination signal and properly handle that situation. Yeah, I'm already kind of running out of time, and I saw that the pizza arrived. So if you are interested in this and want to read more about those non-functional requirements, we did good work there in our documentation for the Velkin platform that Christian mentioned earlier, and it's an open source project, so feel free to take a look at that and use it if you want, or get inspired from that documentation that will tell you actually for each of those requirements also why they are important. So you also know what to do, but not only what to do, but also kind of why you should do it. So if you go to our documentation page, then for application developers, go deeper and prepare your application and scroll, then you will find this list. So key takeaways that I would like you to kind of remember from that is that the cloud native application platforms, they can help you fulfilling the non-functional requirements of your application, of your system. But kind of don't worry, as an application developer, there is still a lot of things to do for you on the application level, and how you use that functionality of the platform in order to to get the all the benefits from that. As I mentioned, I also kind of have the hat of the instructor and the training manager. So if you are interested, I will be coming back to Lund in June and in October for 2 Kubernetes courses for application developers and for administrators. And for administrator, actually, there is one in 2 weeks' time in Umeå, but it's also possible to join online. So if you are interested in that, you can check the schedule. We'll keep also this here available. And finally, before I take questions and so on, I just wanted to mention that it's not only me and Christian from Elasticys that we are here, but we have a few more people. So we have Pavan here, John sitting there in the corner, and Hedvig with us. So yeah, if you want to ask us for anything, just approach. Don't be shy, and we can discuss that while eating pizza.